Assalamualaikum and good morning. Okay, so boleh jawab tak exam semalam? Senang ke susah? Dengar apa suara saya?
Dengar doktor.
Okay. Okay, so boleh jawab tak exam yesterday?
Tak pasti doktor.
Okay, tak apa. Okay, so can you see my slide?
Dapat doktor, dapat.
Okay, so let's start with prayer first. Okay, Bismillahirrahmanirrahim. Alhamdulillahirrabbilalamin. Ar-Rahmanirrahim. Maliki yawmiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. Bismillahirrahmanirrahim. اللهم افتح علينا حكمتك وانشر علينا من خزائن رحمتك يا أرحم الراحمين. Ya Allah, bukakanlah ke atas kami hikmah-hikmahmu dan limpahilah ke atas kami khazanah rahmatmu. Wahai Maha Pemurah lagi Maha Penyayang. Amin ya Rabbal Alamin. Okay. So, last week, okay, so this is the assignment that I gave last week. Okay. So, we should draw a table. Okay. Segment, okay, or part, okay, part, and then centroid, okay, y centroid, okay, x centroid, multiply with area. And then y centroid multiply with area. Okay. Okay, so who want to mana saya punya attendance? Okay, who wants to volunteer? Nanti remind saya siapa nama. Who wants to volunteer first?
Saya doktor.
Sekejap mana saya punya attendance ni? Okay, yang siapa tu nama?
Nurwaida.
Nurwaida, okay. So nak volunteer which one?
Part 1 yang kecil tu depan.
Okay, part 1 kejap. Let me, okay, part 1 yang kecil yang depan tu. Oh, saya tak ni. Sekejap, share. Okay, saya dah ni. Boleh masuk tak dalam Jamboard?
Tak boleh doktor, kena download.
Kena download? Kenapa?
Kena download dulu.
Oh, okay, tak apa. Okay, so sekejap. Okay, saya... Okay, so... This one? Yang ni ke? Okay, part 1 yang mana?
Tu yang kecil tu.
Yang kecil tu yang ni? Yang ni ke?
Bukan yang bawah ke doktor?
Boleh je. Okay, so yang ni? Ni, part 1. Okay, so this is part 1. Okay, so... Okay, 1 and then centroid dia?
Centroid dia 1.
Centroid dia 1?
Dia 1 darab 1 kan doktor?
Oh, area. Okey.
Alau. Sorry.
Saya lupa lah nak balik satu area. Kejap
Okay.
Saya tertinggal area. Okey, tak apalah. Kita buat area kat mana Okey, kita buat area dekat ni lah. Okey, so area dia kejap part 1. Okey, and then saya tambah sini area. Okey, area dia berapa? 1.
1.
Okey, and then at centroid
0.5.
0.5. And then y centroid
0.5.
0.5. Okey, so dekat sini sekejap saya explain. So base dia supposed to be so awak ambil base dia yang ni kan? Betul tak ni base dia?
Betul.
Okay, so base ni dekat sini at centroid. Centroid ke? Y centroid. Sorry. Y centroid. Y centroid equal to 0. Okay, kalau at centroid awak ambil dekat mana base dia? Dekat sini, is it? So this is at centroid equal to 0. Okay. At centroid 0.5. Okay. At centroid multiply with area
0.5.
0.5. Kejap boleh lah. Okay, 0.5. Okay, 0.5. Okay. Lagi y centroid multiply with area
0.5.
0.5 juga. Okay. So done for part 1. Nah, Ruwaidah kejap ni. Okay. Ruwaidah nombor berapa ya? Saya tak ingat lah. Page apa
Pegang page tu silap.
23. Okay. Ruwaidah 1 marks. Okay, dah. Siapa nak volunteer for part 2?
Saya doktor.
Nama?
Fatina Jiha.
Fatina Jiha. Okay, so Fatina Jiha. Okay, so nak start part mana? Which part?
Yang rectangle yang 2 times 3 tu.
Oh, yang ni Ni? Okay, so ni part 2. Okay, so tu area dia berapa?
Area dia
6. Okay. Centroid?
at centroid 2.
2.
Mm-mm.
Tu okay. Lagi?
Y centroid dia 1.5.
1.5.
And then at centroid times area 12. Y centroid times area 9.
9. Okay, Fatina Jiha. Ni. Nombor? Tak ingat.
Nombor 9.
Oh, nombor 9. Betul. 9. Fatina Jiha. Okay, 1 mark. Okay, siapa nak next?
Saya.
Nama? Fatimah? Okay. So, the last one lah kan? Rectangle, triangle kan? Okay. So, triangle part 3. Okay, area?
4.5.
4.5. Okay, next. Centroid?
Centroid 4.
4. Okay, y centroid?
1.5.
1.5?
1. 1.
Kejap. Okay, y centroid 1. Okay.
X centroid tu area tu 18.
18. Okay.
Lepas tu Y tu 4.5.
4.5. Okay. Siapa Fatimah ni? Fatimah. Okay. Banyak ni Fatimah. 1, 2, 3, 4, 5, 6. Okay, thank you. Okay, so siapa nak volunteer total for central area and y tak yalah. Okay, central area sekali dengan dia punya nak kira calculate x and y tu. Ni X and Y. Kita nak cari X ni berapa, Y berapa. Okay, siapa nak volunteer for this one?
Saya doktor, totalkan je kan doktor?
Sekejap total and find out using previous formula which is X centroid. Okay, sekejap mana. Okay, so yang ni formula dia which is summation of this one. Okay, sekali lah summation. Okay, summation area berapa?
Uh, 44.5 doktor.
44.5 summation of area.
11.5.
11.5. Okay. Ni central area ni summation dia
6.5.
6.5. This one 6.5.
Y centroid. X centroid ke?
Central
30.5.
30.5.
30.5.
X centroid plus area.
30. Okay, next Y central area
14.
14. Okay, so this one berapa dia punya ni?
Uh, 2.65.
Sekejap saya rasa something wrong here. Okay. Okay, perasan tak apa yang dekat sini? What's wrong here? Anybody? Before kita calculate this one, apa yang salah dekat sini?
Y centroid.
Y centroid lagi? The biggest fundamental mistake yang kita buat kat sini apa dia? Dia bagi tak Y axis and X axis? Do we have existing Y axis and X axis in the figure?
Oh, dia bagi tengah-tengah tu.
Dia bagi. So what happen is kita kena base on the Y and X axis. Sebabnya kita nak tahu Y centroid dengan X centroid based on axis ni. Okay. Kalau negatif then we will have negative. Kalau positif, sebab kalau kita buat macam ni then okay, let's say kan. Okay, sekejap kita proceed yang tadi ni. Okay, kalau based on this one and this one, berapa kita dapat ni Agi? X centroid dia berapa? Tadi Agi kan yang nak volunteer.
Ya doktor, X centroid dia 2.65.
2.65. Okay, and then Y centroid?
Y centroid dia 1.22.
1.22. Okay, sekejap. Bagi mark dulu dekat Agi. Yang the rest tak nak volunteer ke? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Sebab lepas ni we go for friction tau. So friction ni macam dia more to equilibrium and then we have additional elements which is friction. Okay, so based on this one 2.65 kan. And then this one 1.22. So we have all positive here. Tapi kalau based on this axis, tak boleh kita nak buat. Kalau kita nak buat, then we have to base on, boleh juga. Okay, based on this axis. Okay, contoh macam ni kan. So this is our axis yang kita buat kan. Okay, so it will be x2 Berapa? 2.65. So 2.65 is sini 1, 2. So around here 2.65. Kita ambil sini lah. Let's say macam ni. So this is X2 2.65. Okay, and then Y2 is 1.22. Okay, so let's say dekat sini 1.22. So this is 1.22. This is 2.65. Okay, so maksudnya this is the center of this composite area. Okay, which is 2.65 for X and Y is 1.22. Okay, kalau for dia punya, the real answer will be X is negative 0.3 Kalau dia punya answer, okay. The real answer will be X2, okay, X centroid is negative 0.348. Itulah. And then Y same 1.22. Okay, so this one is correct. Okay, sebab Y dia sama je. Okay, and then dia punya X, okay, 0.348. Okay, so kalau supposed to be, dia kira from here lah, okay. From here, kalau based on this axis, 0. Faham ke? Macam mana kita dapat 0.348 ni? 3 ni minus with 2.65. So then we get negative 0.348 from here. Dikira from this one lah. Okay. This one is negative 0.348. So maksudnya kalau you want to do your own axis boleh. Tapi but at the end location ni or point ni should be based on the given Y and X axis. Faham ke?
Doktor, saya tak faham yang 2.65 tu dapat dari mana.
Yang awak kira ni dapat dari mana?
Bukan yang dari jawapan yang kira dari aksis tengah
Tak, yang ni yang kita buat ni, kita buat axis sendiri tau.
Okay.
So macam kita buat tadi, before yang awak kira semua tu, this is your, what is it? So this is X centroid equal to 0. Faham ke? Memang dia Y axis, tapi inilah based on kita punya, macam mana saya cakap X axis ni, okay, from here equal to 0. And then moving towards here will be positive. Okay? Faham ke? Faham ke?
Faham, doktor.
Yang lain faham ke? Okay, let's say kalau susah sangat, okay, let's say from use the Y and X axis yang existing that is given in the figure already. So kalau macam tu, Y centroid ni maksudnya macam ni Okay, so maksudnya X je, Y centroid ni okay. So X centroid ni kita base on this one. Okay, this is the base for X centroid equal to 0. Okay, kalau macam ni kan, if you say this one, let's say this one kan. Okay, so the middle point for this part 1 area is this one. So here, negative 0.5. Okay, so distance here is 2.0. Then from here to here, it will be apa? Negative. So here,
2.5.
Yes, negative 2.5. Okay, so dekat sini tak adalah negatif mana? Negatif. Salah. Mana tu? Eccentroid. Part 1 here will be negative 2.5 macam tu. Tu ke? Sekejap. Okay, negative 2.5. Okay, nanti oh. Okay, so nanti awak sini bila awak dah harap tu negative 2.4, so negative 2.5. Okay, and then this one awak akan dapat negative 2.5 juga, right? Negative 2.5 multiply with 1, so negative 2.5. Okay. Okay, so nanti area sekejap. Macam mana dia dapat warna negatif ni? Negatif 2.5. Area pun negatif tu. Oh, okay. Okay, so macam tu lah. Faham ke? Kalau nak buat your own axis boleh. Tapi at the end, dia punya ni, dia punya coordinate tu should be based on the given y and x axis. Okay? Okay, so tahu tak function dia apa? Why we want to calculate the center of this composite area? Anyone can guess? Free mark je ni. Okay, so let's see kan. Okay. Okay, so based on yang kita kira tadi, the center is here. Uh, 1.22. Okay. 1.22. And then dia punya x is negative 0.38, something like that kan. So here lah. Okay. Negative 0.348. Okay. 348. Okay. So this is the center of the. And then let's say. Okay. So let's say this is, we have, let's say we have tension here. Okay. And then let's say we have, sini we call it, A lah. This one B. Okay, let's say A here we have AY. And then for B, let's say we have BX. Okay. Okay. And then yang ni will be what? Apa kat sini? What is the force there? Should be weight. Kan? Okay. So that is the function why we want to find the composite area, the center. Okay. The center of the composite area. So inilah function dia. Okay. Faham ke? Okay, kalau faham, then I want to go for new topics. Any question for this topic?
No, doktor.
No, okay. The rest ni saya tak dengar suara pun. Tengok ke tak ni? Ada ke tak ni?
Ada.
Ada doktor.
Sekejap mana tadi saya nak share. Lecture notes. Friction. Mana saya nak share ni? Okay. Window. Okay, nampak ke saya punya slides ni?
Nampak?
Okay, so we go into new topics, which is friction. Okay, friction. Okay, so for introduction, ideal assumption, forces between contacting surface act normal to the surface. So friction ni is a force between contacting of surface act normal to the surface. Okay, real surface. There are tangential forces between contacting surface, which is equal to friction force. Okay, friction force occurs when one contacting surface tends to slide along another. Minimize the effects. Okay, so to minimize the friction effects, we have bearings, okay, screws, gears, flow of fluids in pipe. Okay, so then these things can avoid loss of energy through frictions. Okay, to maximize the effects of friction, we have brakes, clutch, pad drives and wedges. Okay, kita nak maximize effect ni sebab kita nak stop the movement. Okay, contoh your kasut kan, your kasut is made from rubber something like that lah, sebab dia nak maximize effect to stop the movement. Okay, kalau let's say you want to minimize the movement, let's say macam let's say skating shoes kan. So okay, skating shoes, macam mana saya nak lukis Sekejap. Let's say for skating shoes, ice skating. Pernah pergi ke ice skating dekat IOI tu?
Tak.
Oh, pernah pandai dah ni. Okay, so let's say mana saya template ni. Sekejap. Okay. Sekejap nanti I share with you. Skating shoes and shoes. Okay, sekejap. Okay, nampak tak? Ini kita punya, okay, the left one yang shoes biasa yang kita pakai. Okay. Okay, the right one on the right hand side is ice skating shoes. Okay. Kalau normal shoes yang kita pakai tu, the area is quite large. Okay, we have large surface area. Okay, this one to maximize, tak nampak, to maximize the friction. Okay, but this one you want it to stop the movement. Okay, and then this one, dia punya surface area is very minimum. Okay, minimum small area. Okay, small surface area. And then this one to minimize the friction. Okay, this one we don't want to stop the movement. Okay, kalau ikut slide tadi mana? Okay, kita nak avoid loss of energy. Sebenarnya kita nak ni lah, we don't want to stop at all. Okay. Apa don't want to stop the movement. Okay. So that is what is friction about. Okay, simple introduction. Okay. How many types of friction that we have? So here we have 1, 2, 3. 3 types of friction. Okay, the first one is dry friction. It is unlubricated surface in contact under a tendency to slide. Friction occurs in the direction opposite to the impending motion called Coulomb friction. Okay, and then second type we have fluid friction. Adjacent layers in a fluid are moving at different velocity. Okay, and then the third one we have internal friction. Solid material under cyclical loading. Okay. Okay, so this is dry friction, convection. Okay. First we go for dry friction. Okay. Sebenarnya ni akan banyak kita play along, which is dry friction. So mechanism of dry frictions. Okay, first in this A diagram ni we have a mass object. Okay, and then we have pull. P ni for pulling force. Maksudnya kita pull this object to the right. Okay, so what happen is surface ni it will be smooth or boleh conteng tak? Tak boleh. It will be smooth or rough. Supposed to be rough. Kalau smooth, there will be no friction. Kalau surface too rough, baru we encounter with friction. Okay, so what happened here is, so we have, okay, pulling force ni to the right. Okay, and then friction will be opposite to the movement. Sebab kita nak friction ni function dia untuk to stop the movement. So what happened, it will move to the opposite direction of movement. Movement to the right, and then friction will be to the left. Okay, and then we have N. N ni apa? Normal force to the surface areas. Okay, and then if we combine F and N, okay, we will come out with R, resultant force. Okay. Okay, this is the simple one. Okay, in C ni, let's say we have a lot of frictions. Okay, macam nampak tak? Dia contact surface ni, we have 3 points. Okay, where the surface, where the object meets with the surface. So, point 1, we have F1 and N1. So, combined, we have resultant 1. At point 2, we have resultant 2. At point 3, we have resultant 3. Okay, so this is the graph, which is, okay, F ni stands for friction. P ni stands for the pulling force too. Okay. Okay, so this one, it will go, macam kat sini maksudnya, kalau pulling force 2 is greater, okay, for this part friction also will be greater. Okay, so this is the first part ni, the first phase ni, we call it static friction, no motion. Okay, and then sampai dekat this point, we call it impending motion. Okay, so here F max ni, okay, which is impending motion ni, Okey, dekat sini tak bergerak lagi. Objek tu tak bergerak. Tapi once dia nak bergerak, it will reach friction maximum. Okey, nak cari friction maximum for static friction ni, Fmax is equal to, friction maximum is equal to mu S. Okey, mu S ni, mu static ni, coefficient of static friction. Okay, S ni stand for static friction. Multiply with any normal force. Okay. Okay, and then for the second phase ni, we have kinetic friction for motion. Dekat sini it start to move. Okay. So this one, okay, FK ni stands for kinetic. Okay, kinetic friction equal to mu K is static coefficient for kinetic friction multiply with normal force. Okay. So dekat sini SP will be greater, friction will be lesser, will be reduced. Okay. Faham ke? Okay, then kat sini apa Okay. So this is how we calculate the one that I explained here in the graph here. Okay. Fmax ni stands for limiting value for impending motion. Okay. Okay, so here we have, okay, so dekat sini saya tak fokus dekat cone lah. Okay. Okay, the direction of R, which is resultant force, is specified by tan alpha is equal to F multiply divide with N. Okay, biasalah. Tan alpha is tangent. Tangent apa formula dia? Opposite divide with? Kan? Tangent.
Attention.
Tangent equal to
Opposite over adjacent.
opposite over, adjacent. Okay. TOA. Okay, so TOA. Okay. Tangent is equal to opposite divide with adjacent. Okay. So opposite of alpha is F. Betul ke? Okay, faham ke? Sekejap. Saya nak lonteng ni macam mana? Sekejap, print screen. Okay, here we have, okay, tadi apa? We want to find tan alpha. Okay, so is equal to opposite over adjacent. Okay, so opposite of, okay, so let's say this is alpha. Okay, and then we just bring down the F over here. Okay, so this opposite of alpha is F. Okay, this one is F. Is equal to F over adjacent, which is equal to and adjacent to alpha tu. Okay, so that's why lah we get mana tadi? Okay, betul ke? Okay, tan alpha is equal to friction divide with N, normal force. Okay, when the friction force reach friction maximum friction, okay, the angle alpha reach a maximum value tau, this one is what tau, this one lah. Okay. Okay, so Okey, jap. Yang ni saya tak fokus lagi. Okey. Corner of friction, I did not focus. Okay, so this one. Motion is impending. Okay, body about to slip. Okay, dekat sini maksudnya body tu nak start to move. The object start to move. Okay. So this is the formula based on graph tadi tu. So friction maximum is equal to coefficient of static friction multiply with normal force. Okay. Second, friction problems. Okay, friction problems. And then, okay, condition of motion is not known. Find friction force F from equilibrium equation. Okay, so yang ni yang kita kena find out from equilibrium equation tu. Okay. Equilibrium equation tu this one yang summation of Fx equal to 0, summation of Fy equal to 0, and summation of moment at certain point equal to 0. Okay, from that we can find type of friction problems. Okay. Okay, for the first one we have if F less than F maximum. Okay. So the body is in equilibrium and friction force is equal to F. Okay. Second types we have second types of problem we have if friction equal to friction maximum. Okay. Impending motion okay, yang ni So yang ni yang kita akan banyak guna to determine either the body is the first one, body is in equilibrium and friction force equal to F. Second problem, body is in equilibrium, motion is impending. Okay. And the third type of problem we have if F more than F maximum, okay, it is impossible, not in equilibrium. Okay. Okay. Third problem we have relative motion. Okay. So this is when the object start to move. Okay. Kalau dia dah lepas this point, okay, maksudnya dekat sini graph ni, if you see the graph, first dia akan F ni will be equal to pulling force. Tapi at certain point bila dah sampai maximum dia, okay, so maximum friction equal to coefficient of static friction multiply with force. If it pass this limit here, so it will start to move. Okay, the object start to move. So this is the formula to find the friction when the body moves. Okay. Okay, so this is formula same je tadi. Static of coefficient kinetic friction multiply with normal force. This happen when the body start to moves. Okay. Okay, sample problem. Okay. Sekejap which one is simpler? Sama je. Okay, so for this one, okay, so basically kita ada physical class, right? Okay. So what you have to do is, okay, so let's read the question first. Determine the range of values which the mass MO here, okay, may have so that the 100 kilogram block will neither start moving up the plane nor slip down the plane. Maksudnya dia tak move lah. It's not moving outward or downward. Okay, so it will be static. Okay. The coefficient of static friction for the contact surface is 0.30. Okay. So sekarang ni kita kena determine apa this one. The mass of MO here. What is the kilogram of this object MO? Okay. So do you know what you have to do first? First step apa? Okay, so what I want you to do is draw the what?
Free diagram.
Pandai pun. Okay. Draw the free body diagram. Okay, so first task tomorrow is draw the free body diagram. Okay, and then at the end of the class we should solve this problem. Okay, and submit to me at the end of the class. Okay. Okay, draw this free body diagram of this object. Okay. That's all for today. Okay. So any question? Okay, no question then Alhamdulillah. Okay, terima kasih semua. Assalamualaikum.
Thank you,
Salam, thank you, Doktor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Doktor.
Thank you, Doctor.